We're going to take a quick look at the mean value theorem and use it to find the average value of a function over a given interval. If you recall, the fundamental theorem of calculus kind of gave us directions on how to calculate the definite integral. But the other thing that came out of it is that this was how we represented the area under a curve. Now the mean value theorem gives us another way to represent that area under the curve, or how to calculate that indefinite integral. It says that if f is continuous on the interval from a to b, then there has to be some c on that interval such that the definite integral is f of c times b minus a. So we can calculate that area in two different ways. Let me show you what I mean. From the fundamental theorem of calculus, we got that the area under this curve on the interval from a to b was that definite integral. And we found that by taking the antiderivative of f of x and evaluating it from a to b. That's where we get the f of b minus f of a. But what the mean value theorem says is that there's some point on the interval from a to b, we'll call it c, where that exact same area can be represented like this, where the base of that rectangle is the b minus a, and the height of that rectangle is just the functional value at c. So let's consider the line f of x equals x plus 1 on the interval from 1 to 5. Let's find that c that the mean value theorem is talking about. Well, the mean value theorem is saying that there is some c, where f of c, some c in here, where f of c times the width of the interval, that 5 minus 1, is equal to the definite integral from 1 to 5 of f of x dx. Okay. So when we calculate that, that would be 4 times f of c is equal to the integral of x plus 1 would be 1/2 x squared plus x evaluated from 1 to 5. So when we do all of that calculating, plugging in 5 first and then subtracting what we get when we plug in 1, we should end up with 16. Finish off by dividing by 4, and f of c is equal to 4. Now that isn't what c is. That's what the height at c is. What I want to do is to find out what is that c. Well, f of c would be c plus 1 if we just plug c into f of x. And that value should be 4, so c should be 3, which means right here is the c that we're talking about. And the area of this rectangle would be the same as that 16. Let's try another one. Consider g of x being sine of x on the interval from 0 to pi. Let's find that c that's guaranteed by the mean value theorem. All right, mean value theorem would say that g of c times the length of the interval, so pi minus 0, is equal to the definite integral from 0 to pi of g of x, that's sine x dx. Right. So we have pi times g of c is equal to negative cosine evaluated from 0 to pi. When we do that calculating, plugging in pi, cosine of pi is negative 1, so the opposite of negative 1 is 1, minus, when we plug in 0, negative cosine of 0 is negative 1. So that's going to be 2, and when we divide both sides by pi, g of c is 2 over pi. Now that's not what c is, that's what g of c is. So that's going to actually be the height of that rectangle. to find out where that happens, g of c is equal to the sine of c when we plug it into this function, and its value is 2 over pi. So to solve for c, we would just take the inverse sine of 2 over pi. And if you go to your calculator and calculate that, you'll get about 0.690, right, which means about right here, where we'll have a rectangle. The height of that rectangle is going to actually be 2 over pi, and the area of this rectangle would be the same as the area under that curve. So we were able to represent that exact same area in two different ways. And if we think about like Riemann sums and how we first initially estimated areas and led into that definite integral, when we were dealing with g of x being the sine of x, we would have used Riemann sums like this to add up a bunch of these rectangles, infinitely many of these rectangles, all having these different heights, and adding them all together. Now, when we move on to the rectangle, doing it in a Riemann sum sort of way, we would have infinitely many rectangles like this. However, all of these have exactly the same height, which is kind of important because that word average or mean, when we think about what average is, we have this implication that everything's the same. You know that when we calculate an average in that algebra 1 sort of way, we add up all the numbers and divide by the number of numbers. You know, think of it in as like a money sort of thing. It's a real, you know, communist sort of idea that we're going to take all the money and put it in a pile and then distribute it equally to everybody. You know, and that's what an average or a mean is talking about. So when we're trying to identify what the average value of a function is over an entire interval, it would be that value that if they were all the same, this is what they would be. And that functional value would be right here at that g of 0.69. So now if we generalize from the mean value theorem, we had that g of c times pi was equal to the integral from 0 to pi of g of x dx. If we want to know what the average value is, it's going to be that g of c part. And to get g of c alone, we have to take that integral and divide it by the width of the interval. More formally, the average value of a function f of x, if f of x is integrable on the interval from a to b, then the average value of f of x over the interval is going to be that definite integral divided by the length of the interval. All right, so the integral from a to b of f of x dx, all divided by b minus a. So if we want to find the average value of k of x is equal to 3x squared minus 2x over to the interval from 1 to 4, that would mean that to find the average value, we're going to take the integral from 1 to 4 of the function divided by the width of the interval, 4 minus 1. And so that's going to be 3. I'll just keep that out here as 1/3. The integral of 3x squared minus 2x is going to be x cubed minus x squared, evaluated from 1 to 4. Plugging in 4, we'll get 64 minus 16. Plugging in 1, we'll get 1 minus 1. 64 minus 16 is 48, and 48 divided by 3 is 16. So the average value of that function on the interval is going to be 16.